Alright guys, I just want to take a look at this activity and go through the first two problems and kind of get you started on this. So this is work talking about impulse, and so from episode 2 of season 6, so season 6 episode 2, define impulse as a force acting on an object over time. And so mathematically it can be written as force F times T. Now another way we can look at this impulse, is by taking a look at a graph of the force on the object over time. And since impulse is force times time, for this graph, it turns out that the area under the graph will give us force, which is on the y-axis, times time, which is on the x-axis. So mathematically, the area under a curve will give you whatever's on the y-axis multiplied by whatever unit is on the x-axis. We've done this before with slope, where if you have a graph, the slope of the graph is whatever's on the y divided by whatever is on the x. So the area under the curve will give you y times x. And in this case, force times time is impulse. So to find the impulse, we simply have to find the area under the curve. Once we have that impulse, to do B, I know that impulse equals a change in momentum. A change in momentum is mass times the change in velocity. I know the final velocity is 25. So what I can do is once I have my impulse, I can find what the change in velocity is, and then I can work backwards to figure out what was the initial velocity of the car. For number 2, the same principle applies. We have a graph of force over time. We can then find the area under this graph to calculate the impulse on the golf ball, and then from that we can work backwards using this equation to calculate the velocity of the golf ball after it leaves the tee. So that's how you connect impulse to momentum using graphical analysis. Let me know if you have any questions.